Hello guys, so we are back again, and in this lecture we are going to do some couple more questions on GP. Okay, the first question is as follow. Okay, the question says find the product of 11 terms of a GP whose sixth term is 5. Okay, now uh, you can do this question by two ways. Okay, if you know this property. Which property? The property is as follow, that tn square is equal to tn minus k and tn plus k. Remember, I told you this property. This is an important property. Okay, now if you know this property, you can do it by this property, or there are some other methods to do it also. So if you know this property, so there are 11 terms, so t1 and t11, okay, they will form n plus 1, will be equal to what? T2 into t10, they will again form n plus 1, t3, t9, similarly goes t4, t8, t5, t7, and last the t6, okay, square, they will be equal to t6 square. Okay, now what I want to find the product of a1, a2, a3 till what? a11, all the terms. Okay, they are nothing but, if I count them 2 to 2 like that, they are nothing but t6. Okay, t6, okay, t6 power what? 2 into 5. Okay, it is equal to t6, and how many times? 1 2 3 4 5. Okay, and 1 will be also that is t6 separately, so it will be what? T6 power 11, and t6 is what? 5 power 11. So this is our answer. Now what was that? t1 is equal to t11, n plus 1 concept we did for till all the number. Now t6 is the middle term. Okay, so it will be t6 square. Okay, you can also understand it like t7 here, t5 here, t4 here, t8 here, so moving equal distances like that. Okay, if you will more understand using this thing. Okay, now one more thing, we did that, and then we multiply. We can use this to call it as a t square. We can use t2 and a10 and call it as a t square. Similarly, we can use a3 and a9, we can call it as t square. Okay, t6 square. Okay, then what we can do, we can add t6 power the whole raised to 5 into t6. Okay, so t3 into t9 will form t12. Okay, that is n plus 1. The b middle term will be t6, so this will form t power 6 5 times into t6 will give me t6 11. Okay, so whole t6 is what? 5. Okay, so 5 power 11. So we got this thing. Okay, now the second method. Okay, second method. Okay, second method or method 2, which whatever you want to say. Okay, method 2 is nothing but, if you remember one more thing when we were learning GP. Okay, these terms are GP. When there is odd number of term, GM is what? A power n plus 1 by 2. If you remember properly, a power what? 11 plus 1 by 2. There are how many terms? Okay, 11 plus 1, total number of terms means a6. Okay, now if you find, the GM can also be written as a1 into a2 into a3 till what? a11, all will combine form a n plus 1. Okay, that condition is also satisfied upon 1 by 11. It should be equal to a6. Okay, because this is GM and this is GM. Okay, both should be equal to this. That is what we wanted to find. Okay, is till a11 is equal to what? a6 power 111. Okay, which is nothing but 5 power 11. So this was the other method to do the same problem. Okay, depends on the approach, okay, which you take. Second method was what? GM is nothing but the terms which you have taken should be 1 a n plus 1. They should form n plus 1. Okay, n plus 1, the whole power 1 number of terms, 1 upon number of terms. Okay, when it goes for 6, okay, in middle, in GM we can directly know if there are odd number of terms and it is a GP, the terms are in GP, then we can apply the trick that it should be equal to n plus 1 by 2, direct middle term. That is the formula which I told you. Okay, that is the trick. Okay, when the sequence is a GP. Okay, now, and using that we got this, and okay, there was nothing great in this. Okay, so we are going to move on to the next question. Okay, the next question is question number 2. Okay, the question number 2 is as follow: if the 4th, 7th, 10th term of a GP are P, Q, R respectively, then Q power M is equals to PR. Find M. Okay, now fourth term is P into A R power 3. Similarly, 7th term is Q into A R power 6, and R term is nothing but A R power what? 9. Okay, now what we can do, we can substitute the values. Okay, if I substitute p value, a here will be what, 3m. Okay, what is q? Q is nothing but 6m, and this is nothing but m. Okay, similarly if here I substitute these two, this will be a square into r3 plus 9 will be what, 12. Okay, now if I equate them, m is equals to 2 from here, or let me check the second one, m is equals to 12. Okay, we are getting m is equals to 2. Okay, so m is equals to 2. Now using the second trick, what is the second trick? If I see t7, okay, if I see t10, and if I see t4, they are equal distance from t7. Don't you get this point? They are equal distance, so I can write t7 the whole square should be equal to t4 into t10. Okay, similarly then what we can write, q square should be equal to p into r. Okay, so q square, so if I compare this with qm should be equal to pr, what I get, m is equals to 2. So m is equals to 2 is the answer, right? This is what, this is method 2. Okay, now let's move on to the next. Further what we have this question number 3, which says as follow: if mod x minus 3 comma 3 and mod x minus 3 are the first three terms of an increasing AP, then find the sixth term of an AP. Okay, of an increasing AP. What does it mean? That the difference will not be negative. Okay, it will not be negative of three terms of an increasing AP. Okay, now when we see this type of questions, in inequality we have known that how to deal with modulus. Now we know mod is nothing but greater than equal to 0 condition. So there are how many critical points? 1 and 3. Okay, if it is greater than 3, then all will open like this, x minus and x minus 1. If it is between 1 and 3, this will open as 3 minus x, and this will again open as x minus 1. If it is less than 1, how it will be 1 minus x and 3 minus x. Now take the case 1. Case 1, what is case 1? Case 1 is nothing but x is greater than 3. Then what terms we have? X minus 1, okay, 3, x minus 3, right? These are the terms we will have. Now if they are in AP, then 6 should be equal to, okay, let me make you understand more. 3 should be equal to, okay, 3 should be equal to x minus 1 plus x minus 3 by 2. Okay, after this 6 should be equal to 2x minus 4. What we are getting? X is equals to 1. Okay, we are getting x is equals to 1. No, we are getting x is equals to 5. Okay, sorry, we are getting x is equals to 5. Okay, now let's put this value here. What we have? 4, we have 3, we have what, we have 2. Okay, so the terms are 2, 3, 4. Okay, so what is the d? D is nothing but, okay, let me understand. Okay, the terms are 4, 3, 2. Okay, let me understand. Okay, we cannot change the term order. Okay, one more thing. Okay, I was changing the term order. Sorry, we cannot change the term order. Okay, we are getting 4, 3, 2. Okay, now if you want to find d, what is d? 3 minus 4, it is nothing but minus 1. Similarly, d is what? 2 minus 3, it is nothing but what? Minus 1. But in an increasing AP, d cannot be negative. Okay, so this is rejected. No solution. Okay, no solution. Although it is an AP, but d is not increasing. Okay, d should be greater than, okay, d should not be negative. Okay, it is in increasing, it should add on instead of decreasing. Okay, now let's check the case 2. Let me take the next page. Okay, case 2 is what? X is bit greater than 1 but less than 3. Okay, then what is the scenario? X minus 1 will open like this. Okay, 3 will be like that, and 3 will be the third, mod x minus 3 will open like this. According to the again the same condition, x plus 3 minus x by 2 should be, okay, they are in AP. Then 6 should be equal to minus 2. That is not possible, so no solution from here to, no solution. Okay, now case 3. Okay, case 3 is what? X should be what? Less than 1. Okay, then what we have? 1 minus x, 3 minus x, right? 3 should be equal to what? 1 minus x plus 3 minus x. What we are getting? By 2. Then we are getting 4 minus 2x should be equal to what? 3. We are getting x is equals to this will be 6. This will become what? this will become 6, 6 minus 4. Okay, 6 minus 4 is nothing but 2, 2 minus 2x. Okay, so we are getting x is equals to minus 1. Okay, we are getting x is equals to minus 1. Now if I put x is equals to minus 1, what terms I have? 2, 3 and what? 4. Okay, so here if I check d, 3 minus 2, it is 1, right? And here if I check d, it is 4 minus 3, it is 1. So d is increasing. Okay, d is positive. D is positive. So this is the correct AP. Okay, now we want to find T6. It is nothing but a plus 5d. Okay, which is nothing but, you can also find it by nd, which I told you direct method, but let it be, we have done it directly. Okay, so 2 plus 5, 7. Okay, so we are done with this problem. The main thing was using the, if you know the inequality, then you can do this question. If you don't know the inequality, even though you know the AP, you cannot do this question. Okay, that is the drawback of IIT exams. Even if you know the chapter, if some concept is applicable of different chapter and you have not done that chapter, then you cannot do that problem also, means that chapter is also gone from your hands. Okay, like that. Now let's move on to the next question. Okay, the next question is like this. Okay, the next question is this: if the sequence 1 comma 2 comma 2 comma 3 comma 3 comma 4 comma 4 comma 4 till n consecutive terms have the value, and find the 50th term of the sequence. Okay, we want to find the 50th term of the sequence. Okay, how we can find out? The I will do it with method 1. Okay, then we will discuss with method 2. Method 1, here if you know first term is repeated, what? It is 1 power 1. Second term is what? Second term, how many times is 2 power 2? Twice it is there, 2 power 2. If I do this type of things, 3 power is, okay, it is repeated 3 times. And fourth term is repeated 4 times. Okay, we want to find, okay, 150th term. Okay, when you know that if these terms second term is repeated 2 times, 3 times is repeated 3 times, 4 times is repeated 4 times, then 150th term will not be 150, it will be something else. Okay, and which term it will be? If we got 17 term, then it will be 17, it can be 17, any term can be. Okay, so we want to find that. Okay, now how we can do it? Okay, now if you arrange it, it is 1 power 1, 2 power 2, okay, 3 power 3, okay, it is 4 power 4 and 5 power 5, okay, and so on. Okay, now if I add on all these powers, okay, okay, what we have? 1 plus 2 plus 3 plus 4 plus 5 till n. Okay, this can be written as n into n plus 1 by 2, sum of n natural numbers. Now what we want to find? It 150th term, and this is the sum of all the powers. Okay, sum of all the powers which they are at the top. Okay, it should be what? Greater than equal to 150. Okay, if it is less than or greater than equal to 150, if we can know. Okay, so now this power, if I add all the powers, and if it is should be greater than equal to 150, okay, greater than or equal to 150, okay, then we can find at what n it is greater than or equal to 150. If I add all the powers and if I apply the condition that this power should be greater than or greater than or equal to 150, then I can find the n. Okay, which term at that point, because I know 17 term will be 17 only. Okay, like that. Okay, so I want to find that term only. Okay, so after this, n plus 1 should be greater than equal to 300. Okay, so n square plus n should be greater than equal to 300. Then if I apply 16, okay, 16, because 300, 256 plus 16, no, it is not going. So n is not possible. 16. Okay, n is equals to 17. Let's check for n is equals to 17. It is 17. Okay, 17 into 18, we can do it like that also, into 300. Okay, it is valid. What number it is? C into 18. Okay, so let's, okay, n is equals to 17 is valid. Okay, n is equals to 17 is valid. Okay, so at n is equals to 17th, okay, it will be greater than or equal to 300. Okay, so the least possible means at 17th, okay, 17th term at n is equals to 17 will be repeated like that 17 times. Okay, so it means that it will just keep on. So 150th term will be 17 only. Okay, 16 was there, but the last term 16, okay, it lasted for 256. Okay, 256 plus 16. At that, after that, it just 17 got started. Okay, so this was the method one. It was just analyzing the powers of the, means it is repeated 4 times, then 58 term will be 17 term will be 17 time 8 will be. So why don't I equate this, add the sum of all the powers, and then it should be greater than equal to 300, apply that condition 150, and then find the n value. Okay, this was method 1. Now let's check for method 2. Okay, method 2 says that the first term, okay, if you see, the first term is at one position, the second term is at what, is at the second term is at third position, right? And the third term is at what, sixth position, and the fourth term is at 10th position. Then what will be the nth term? Nth term will be nothing but n into n plus 1 by 2 position. Okay, you can verify this by putting n 2 into 2 plus 1 by 2. Okay, it is coming 3. So 3 position, second term is 3 position. Okay, so n term will be n into n plus 1 by 2 position. Okay, now this is the position. Okay, and what it should be, if it is, we want to put the values here. Okay, try values. Okay, try values. Okay, and by hit and trial we should check which value is closer to 150. Okay, which value is greater than equal to 150, n into n plus 1 by 2. Okay, now here you can directly see that 16 plus 1 is 17. Okay, 8 into 17. Okay, it is less than, okay, 150, while at n is equals to 17, it is what, it is 153. Okay, it is 153. So at 153 n is equals to 17 starts. Okay, no, at 153 it is the last term. Okay, after that it can be 18, but doesn't matter, because at after 150 or before 150 it was 17. That is the important. So n is equals to 17 is the answer. Hope you have understand. Okay, this question is not that, means it was a tough question. Okay, now let's move on to the next question. Okay, the next question is this: find the arithmetic progression consisting of 10 terms. Okay, find the arithmetic progression consisting of 10 terms if the sum of the terms occupying the even position is equal to 15 and the sum of those occupying odd places is equal to 12 1 by 2. Okay, this is fraction. Okay, fraction representation. Okay, now what we should do? Okay, now sum of, so they are telling sum of, okay, it has 10 terms. Okay, sum of odd, so 5 will be odd, 5 will be even. Okay, so sum of even position is 15. Okay, so 5 by 2 into even position will be what, t2 plus t10. These are even position, first and the last even position. Okay, and is equal to what, is equal to 15. So 5 by 2 into a, this will be what, t2 will be what, a plus d, and this will be what, a plus 9d. Okay, so we can do this 5 will cancel out with 15. Okay, we will be only left with, here will be 3. Okay, this will do a plus 5d. Okay, should be equal to what, 3. So we got one condition. Now the second condition is, and the sum of those occupying odd places is, okay, so odd places means 5 by 2 again, odd places is t1 and t9, the first and the last odd places are this, is equal to 12 into 2 plus 1. We multiply this with this and then add this, okay, upon 2. Okay, so 2 will cancel out, which will give me t1 is what, a plus 8d. Okay, should be equals to what, 25. Okay, 5 will cancel out with this, 2a plus 8d should be equal to what, 5. Okay, we got one thing. If I substitute a is equals to into 3 minus 5d plus 8d should be equals to 5. Okay, this will be 6 minus 10d plus 8d should be equal to 5. Okay, so 6, this will be 1, this will be what, minus 2, which will move here, will be 2d. So d is equals to nothing but 1 by 2. Okay, right, 1 by minus 2. Okay, this one. Okay, 1 by 2. So we got d is equals to 1 by 2. Now let's verify for a. Okay, we got d is equals to 1 by 2. When I put a, this will be 5 into 1 by 2. Okay, 5 plus 1 by 2, what it will give me is equals to 3. If I move it that side, what I have, 3 minus 5 by 2, which is nothing but 1 by 2. So a is equals to 1 by 2. Find the arithmetic progression. Okay, so we got a and d, so we have found the arithmetic progression. A and d are the main things which we want to find in arithmetic progression. Oh, this was nothing but just applying the condition and getting the answer question. Okay, now let's move on to the next question. The next question is the question which I find means a very difficult question. Okay, this question is not easy. If n is the set of natural number n and partitioned into groups, s1 is equals to 1, s2 is equals to 2 term 2 and 3, s3 is equals to 4 5 6, like that. Okay, then find the sum of the numbers in s50. Okay, you want to find the sum of the numbers in s50. Okay, now if you observe clearly, if you observe clearly, the s1 has one term, s2 has two term, right? s3 has what, three term. What term are they? 1 2 3 4 5 6, right? Now the last term of s1, okay, the last term of s1 is what, 1. The last term of s2 is what, 1 plus 2 is equals to 3. The last term of s3 is what, 1 plus 2 plus 3, that is 6. Okay, so number before, till number before we have to add. If I want to s4, we will add the number from 1 to 4. Okay, so s4 will be what, s4 will be 1 plus 2 plus 3 plus 4, which will give me what, 10. Okay, like that. So what will be s49? S49 will be what, 1 plus 2 plus 3 plus 4 plus till what, 49. Okay, so let's find the sum of this. Okay, now why we are finding the sum of this? Okay, if I want to find s50 will only be known if I subtract s50 from s49, then only I will know. Okay, then I will get the sum of s50. See, only s50 term. Okay, I know there will be some of other terms also before that, so I want to cancel s49 from that. Okay, so I will get sum of s50. Okay, now let's do this question. Okay, let me take the next page. Okay, let me take the next page. So s49 will be what? S49 will be, I have this is what in AP or in GP. It is in AP. Okay, so how we do, 49 by 2 bracket first term plus last term. Okay, this is the shortest way, so we are doing this 49 into 25, right? So let me calculate it, what it is. Let me calculate the number. Okay, it is 111225. Okay, it is 1225. Okay, now we got s49. Okay, now let's find. Okay, now let's discuss about the first term. Okay, first term of s1 is what, is 1. First term of s2 is what, 1 plus, okay, 1 plus, okay, 1, it is 2. First term, you will itself observe that how the sequence is varying. The first term is what, 3 plus 1, that is 4. The first term is what, a fourth will be what, they have not given us. How we will find s plus 6 plus 1, that is 7. Okay, so from the before, just if I want to s4, the before sum s3, its last term plus 1. Okay, so s50 first term will be what, s49 plus 1, which will be nothing but 1225 plus 1, which is 1226. Okay, hope you have understand this thing. Now I want to find s50. We have already told that how s50 we can find out. Okay, there will be 50 terms. Okay, 50 terms divided by 2. What is the first term? 2 into 1 2 6. Okay, plus 50 minus 1 into what? D is what? 1. Okay, 1 plus 2 plus till 50. Okay, S50. So what we are getting? 25 into 2501, it is equal to 62525. Okay, let me check. Yes, it is 62525. Okay, now similarly we want to find the first term. First term of what? First term of S49. How it will be? S48 last term of S48 plus 1. Okay, now now let me take the next page. S48 last term will be what? S48 last term will be 1 plus 2 plus 3 plus till what? S48. Okay, it will be nothing but 48 by 2 into 1 plus 48. Okay, which will give me nothing but which will give me 48 means 24 into 49. Okay, which will give me 1176. Okay, now for first term of S49, it will be what? 1 plus 1176, which will be 1177. Okay, now we want to find S49. How we can find S49 by 2 into 117. Okay, 117. Okay, we have not written 117 plus 48. Okay, 48 into D, which is 1. Okay, if we solve this, we have 49 by 49. If I divide it by 2, I have 1177 plus 24. Okay, and if we add on it for the 58849. Okay, we have this thing. Now we want to find S50. Okay, which is nothing but all S50 terms minus S49 all terms. Okay, which is nothing but what we get? 62525 minus 58849 by what? By, okay, nothing. If I divide it, what get? 3676. Okay, so this question, in which this question was tough. How we did it? We proceed with S1 is 1, S2 term, S3 term. The last term of S1 is 1, the last term of S2 is nothing but before number, add the numbers before it. 1 plus 2 is 3, 1 plus 2 plus 3 like 6, 1 plus 2 plus 3 plus 4 like 10. So we found the last term of S49 till 49. We got its sum. Okay, what is the purpose of finding the S49? S49 plus 1 will give me the first term of S50. So I got S50. Similarly, I wanted the first term of S49. Okay, S49, how I will get the first term? It is nothing but S48 plus 1. So I found the S48. Okay, S48 here, and I added 1. I got 1176, 1177. Then I got S49 sum. Okay, which was 58849. Then I subtracted both to get the S50. Okay, so this was all which you needed. It was more like tough calculation rather than if you analyze this part. Okay, first term, last term. Okay, then your job is easy. Okay, otherwise if you're not able to click this thing, then this question is tough. Okay, this question means is a lot of problematic question. Okay, you have to make you have to be very sharp, okay, to do this question. Okay, now let's move on to the next question. Okay, which I think is the last question. Okay, the question number 7. If 1 plus 3 plus 5 plus till P, okay, plus 1 plus 3 plus 5 till Q, okay, is equals to 1 plus 3 plus 5 till R, where each set of parent term contain the sum of consecutive odd natural numbers sum, then show that as shown. Okay, odd integers as shown, then find the smallest possible value of P plus Q plus R, where P is greater than 6. Okay, now if you know 1 plus 3 odd natural number sum is what? It is taught it you in old classes. Last time it is 1 minus 1. It is nothing but n square. Okay, or you can study this in principle of mathematical induction, but doesn't matter. You just learn this, that odd number sum addition is nothing but n square. Okay, now here it is odd natural number. Now if you remember the sum, this thing from the last term there is a trick of writing this n square from the last term, which is nothing but 2n minus 1 plus 1 by 2 the whole square. If you calculate it, you get n square. Okay, so here the last term is P. So if I add plus 1 by 2 the whole square, okay, so I can write this as like this, and this as Q plus 1 by 2 the whole square, and this as R plus 1 by 2 the whole square. Okay, now what if I remove all the 2? What I have? P plus 1 the whole square plus Q plus 1 the whole square plus R plus 1 the whole square. Okay, okay, this is what we got. Now further on, what we can do next? Okay, if you observe, this is forming a Pythagoras triplet. That's why this question is tricky. Okay, it is forming a Pythagoras triplet. Now what is Pythagoras triplet? They are verifying three numbers which satisfy the condition a hypotenuse square is equals to square of other sides. Okay, okay, so you will directly say the triplets are 4 6. Okay, 4 5 6. Okay, no, what were the basic triplets which we were taught? Okay, let me think. What this triplet is not right. Okay, what triplet we should take? Okay, 3 6 3 4 5. Is this triplet right? Yes, it is forming triplet, but it is not right. Okay, it is not right because p should be greater than 6. Okay, here all the terms are less than. Okay, less than what 6. Okay, so we want to think about the next triplet. Okay, what is the next triplet which we can think? 8. Okay, the next triplet which we can think is 8 6 10, right? 8 6 10. Okay, so p plus 1 should be what? 8. Q plus 1 should be what? 6. And R plus 1 should be what? 10 for this triplet to be formed. Okay, this is the most. Why we rejected this? Because p should be greater than 6. That way I was not able to I understand why this triplet was wrong. Okay, so after observing this, I understand that this triplet is not valid. Okay, so what we are getting p value? We are getting p value as what? 7. We are getting q value as what? 5. We are getting r value as what? 9. So we got p q r value. How we got? We just identify the triplet. Okay, now listen, one more mistake which children do. They place 6 here. Why? Because p is greater than 6. You cannot do that. Okay, use 6 here. Okay, you cannot put 6 here also. Why? Because r plus 1 should be equal to these two. Okay, that is the basic Pythagoras theorem. Okay, you should know that. Okay, the highest possible term is in the hypotenuse. Okay, then only they will be equal. Okay, now we got the p plus p q r value. Now let's put the value and check what is p plus q r. P plus q plus r is nothing but 7 plus 5 plus 9, which is nothing but 12 plus 9, which gives you 21. Okay, so this is our answer. Okay, now we are done with the GP. Okay, and we have done some couple questions of AP also, and we will start with HP in the next lecture. Okay, we have done a lot of questions on GP. Okay, I get about 60 to 64. Okay, like that. So take care, and we will continue doing our work. Okay, in the HP. Okay, see you. Bye.